G Wood, possibly donor. Hope I can help you guys out on this. So I got Wood's text about the whole thing about negative velocity being an issue. So hopefully I can make it a little less muddy for you. If I'm not claiming I can make it clear, but the whole idea of positive and negative velocity has more to do with, is basically just direction. So if you imagine a number line where, on a number line we typically have a zero position, and then we have, the numbers going in the positive direction, and then we have the numbers heading in the negative direction. Oops. All right, hold on. I'm doing this on the fly, so pardon the mistakes. In the positive, negative direction. So I want you to imagine like you're driving a car with an oil leak, or you're eating ice cream and dripping, and so the drips are coming at like a regular time, like every second or every half a second or something, at regular time intervals. And maybe try to imagine that that you start here at this position, and then those drips happen, at regular time intervals. And I don't know why, of course, it's not letting me draw where I want to draw right now. So I guess I'll just do it down here. So you start the zero position, and you're drip, 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 drip. You're walking at a constant velocity that way. Now, if I just stick to those dots, like if I walk up on you after I'm seeing those dots, I look at those dots, I have no idea what direction you've gone. So that's where, so then what I would do is I'd fill in between those dots with an arrow showing me that it's going in that direction. Okay? Well, on a standard number line, we've decided that to the right, positive is to the right. It doesn't have to be this way, but that's just kind of what we're all used to, so I'm going to use that example for now. Well, I want you to notice where all my little miniature velocity vectors are pointed. All those little vectors are pointed where? Of course, they're pointed to the right in the direction that we've decided is positive. So we would refer to this as, since I've decided that right is positive, I would refer to this as a positive velocity. Again, sorry, I'm doing it on the fly. Okay, let's maybe have another example where I'm starting here, and I'm walking this way, my little ice cream cone is dripping along, and then I decide to go back to the counter and get a napkin. So I turn around, and then drip, 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 back to the counter. Okay? Now if I draw in my little velocity vectors, as I'm walking away, notice where all my velocity vectors are pointed. They're pointing in to the right, which we've decided is a positive direction. Okay? However, on the trip back, to get from this dot to this dot, I had to go that way. To get from this dot to this dot, I had to go that way. Notice now that my velocity vector is pointed in the opposite direction, in a direction that, remember, we've decided that this way is positive and this way is negative. Since all my little velocity vectors are pointing towards, I'm sitting here making hand gestures, I know you can't see, but since all my velocity vectors are pointing towards what we've decided is the negative direction, I would refer to those as negative velocity. I don't know if that explains everything well. If not, you guys know you can always bug me for more. I noticed that the screenshot or the picture that Wood sent me had to do something with graphing. That might be another discussion for another day. But just let me know if you need anything else, or if we can ever get together on any of this stuff. All right, talk to you guys later. Take care.